my dear students. I hope you all are fine in this pandemic. Now let us start today's lecture of class 7, chapter 1, rational number. Please students, say me, what do you mean by rational number? In previous class you know what is set of natural number. N is called the set of natural number. Natural number is the number, counting numbers are called natural number. Then W is called the set of whole number, which includes all natural numbers including 0. But 0 is not a natural number. Then Z is called the set of integers. This contains all negative integers and positive integers. Up to minus infinity, to minus 4, minus 3, minus 2, which contains minus 1, 0, 1, 2, 3, up to infinity. This is called the set of integers. The chapter 1, rational number. Rational number is the number which can be expressed in the P by Q form, where P and Q are in the lowest form and Q is not equal to 0. Then Q is the set of rational number. Then Q is called the set of rational number in which is in P by Q form, such that P and Q are in lowest term, means simplest form. Are in simplest form, means they do not have any common factor and Q is not equal to 0. This is the conditions of rational number. From these discussions, we come to the conclusion that natural number is a subset of N, is a subset of W, W is a set of Z, Z is a subset of rational number. This means all natural numbers are rational numbers, all whole numbers are also rational numbers, all integers are also rational number. Means the rational number are those numbers which can be expressed in P by Q form, where P and Q are in the simplest form. The simplest form means P and Q do not have any common factors and Q is not equal to 0. Suppose 5 is a natural number, then 5 can be represented in the P by Q form, means 5 is equal to 5 upon 1. Here 5 and 1 are in lowest form, means 1 and 5 do not have any common factors and 1 is not equal to 0. This natural number, all natural number can satisfy the properties of rational number. This means all natural numbers are called rational numbers, but all rational numbers are not natural numbers. Suppose 5 upon 3. This is a rational number, but is this a natural number? Is this a whole number? Is this a integers? No, this is a rational number. Rational number are those numbers which can be represented in the form of P by Q. Suppose I say 0 is 0 a rational number? Yes, 0 can be represented in the form of P by Q, because if I write 0 is equal to 0 upon 1, am I wrong? Am I wrong, students? No, 0 and 1 are in simplest form. They do not have any common factors and 1 is not equal to 0. This means 0 is also called a rational numbers. Now let us discuss about the properties of rational numbers. All fractions are also called rational numbers. Suppose 7 upon 2. This is a fractions. This is also a rational number, but all rational numbers are not fractions. Suppose minus 3 upon 5. Minus 3 upon 5 is also a rational number, because minus 3 upon 5 in P by Q form, where P and Q, minus 3 and 5 are in simplest form, and and an important factor is also P and Q are the integers. What are P and Q? P and Q are integers. Here minus 3 and 5 are integers and 5 is not equal to 0. This is minus 3 upon 5 is a rational number but not a fractions, because fraction means positive rational numbers are called fractions. Understand? Now let us discuss some properties of rational numbers. You know what is closure property? You know what is closure property? Closure property is the property if P and Q. Closure property. Suppose A by B and C by D are two rational numbers. This shows that A upon B plus C upon D is also a rational number. This is the closure property. Now let us discuss some examples. Suppose 1 upon 2 and 3 upon 5. These are rational numbers. Then 1 upon 2 plus 3 upon 5 is equal to 10 is the LCM. Then 5 plus 6, which is equal to 11 upon 10. This is also a rational number. Now take another example. Suppose 0 is a rational number and minus 2 upon 3 is also a rational number. Then 0 plus minus 2 upon 3, which is equal to minus 2 upon 3. This is also a rational number. This means rational number satisfies the closure property. The rational number satisfies the first property, closure property. Now let us discuss the second property. Second property is the commutative property. What do you mean by commutative property? Commutative property of additions. Here we discussed all these properties of additions. Properties of rational number on additions. Commutative property means suppose A by B plus C by D is equal to C by D plus A by B. A upon B and C upon D are two rational numbers. Then A upon B plus C upon D is equal to C upon D plus A upon B. This is called the commutative property. Now let us discuss some examples. Keep this here and now discuss some examples based on this commutative property. Now let us discuss. Suppose 2 upon 3 and 3 upon 5 are two rational numbers. Now 2 upon LHS says that if it satisfies commutative property, this means 2 upon 3 plus 3 upon 5 must be equal to 3 upon 5 plus 2 upon 3. This is called the commutative property. A upon B plus C upon D is equal to C upon D plus A upon B. Now let us take the LHS. Here the LHS is equal to, take the LCM of 3 and 5, which is 15. Then here 10 plus 9, which is equal to 19 upon 15. The LHS is 19 upon 15. Then take the RHS. If LHS is equal to RHS, then we say that this satisfies the commutative property. A upon B is plus C upon D is equal to C upon D plus A upon B. Then here the LCM is 15. Then this is 9 plus 10, which is equal to 19 upon 15. This is RHS, this is LHS. Here we get LHS is equal to RHS. This means this satisfies the commutative property. Now let us discuss the property 3. What is the property 3 says? Property 3 says this is associative property. What property? Associative property. Associative property means suppose A upon B is a rational number, C upon D is another rational number, and E upon F is another rational number. Then the associative property says that A upon B plus C upon D plus E upon F is equal to A upon B plus C upon D plus E upon F. This means addition of rational number satisfies the associative property. This is the associative property. Now take some examples. In the next page we will take some examples and prove that the addition of rational number satisfies the associative property. Okay students, please note down the important points. The first property, closure property. Second property, commutative property. Third property, associative property. Then here the examples of closure property. Here the examples for commutative property. Here in next page we will discuss some examples of addition of rational number which satisfies the associative property. Then I erase it, and in my next page I will discuss some examples. Here now take some examples to prove the associative property. Suppose 2 upon 3, 3 upon 5, 7 upon 2 are three rational numbers. Please students say me, are these three rational numbers? Please take it. This is minus 2 upon 3. Yes. Are these three rational numbers? Yes, these three are rational numbers because all these three satisfies the properties of rational number, because all these three are in P by Q form, where P and Q are in simplest form and P and Q both are integers and Q is not equal to 0. Now let us prove the associative property. What is the associative property? Says associative property says A upon B plus C upon D plus E upon F is equal to A upon B plus C upon D plus E upon F. Here A upon B is minus 2 by 3, C upon D is 5 upon 3 upon 5, and E upon F is 7 upon 2. Now let us take here minus, take the LHS. Then what the LHS says? The LHS is minus 2 upon 3 plus 3 upon 5 plus 7 upon 2. Then here the RHS is minus 2 upon 3 plus 2 upon 3 plus 3 upon 5, and which will be plus 7 upon 2. Now take the LHS. The LHS is minus 2 upon 3 plus 3 upon 5 plus 7 upon 2. Take the LCM of, here this is minus 2 upon 3 plus LCM of 5 and 2 is 10. Then this is 6 plus 35. Then which is equal to minus 2 upon 3 plus 41 upon 10. Then here 10 and 3, the LCM will be 30. Then this is minus 20 plus 123, which is equal to 103 upon 30. This is LHS. Then take the RHS. If we get the same result, then we say that LHS is equal to RHS. This means addition of rational number satisfies the associative property. This is minus 2 upon 3 plus 3 upon 5 plus 7 upon 2. Here the LCM of 3 and 5 is 15, and here minus 10 plus 9 plus 7 upon 2. Then here this is minus 1 upon 15 plus 7 upon 2. Then 15 and 2, the LCM is 30. Then this is minus 2 plus 15 7 ja 105 5, which is equal to 103 upon 30. Then this is RHS and this is LHS. Look at here. The LHS is 103 upon 30 and we get the RHS is also 103 upon 30. This means we come to the conclusion that LHS is equal to RHS. This means addition of rational number satisfies the associative property. Addition of rational number satisfies the associative property. Now let us discuss about the properties of inverse and identity. Let us discuss the at first closure property, then next commutative property, third associative property, fourth identity property. 0 is called the additive identity. This means suppose a upon b is a rational number. A upon b plus 0 is equal to 0 plus a upon b, which is equal to a upon b. This is the property, identity property. Which property? Identity property. 0 is called the additive identity. This is called the identity property. Let us take an examples for better understandings. Suppose minus 3 upon 11 is a rational number. Then to prove the identity property, 0 is called the additive identity. This means minus 3 upon 11 plus 0, which is equal to 0 plus minus 3 upon 11, which is equal to minus 3 upon 11. This shows that addition of rational number satisfies the identity property. Then next property is inverse property. What do you mean by inverse property? Inverse property means for all p by q is rational number, there must exist minus p by q such that p by q plus minus p by q, which is equal to 0. Then now take an examples for better understandings. Suppose minus 7 upon 3 is a rational number. For minus 7 upon 3, there must exist a inverse minus of minus 7 upon 3, which is equal to 7 upon 3. If we add minus 7 upon 3 plus 7 upon 3, then we get 0. This means this satisfies the inverse property. Take another examples. Suppose minus 4 for then minus of minus 4, which is equal to 4. Then minus 4 plus 4 is equal to 0. This means addition of rational number satisfies the inverse property. Then now let us discuss how can we represent the rational numbers in a number line. Do you recall what is the number line? For natural number, this is the number line from 1, 2, 3, 4, 5. This is the natural number line. But this is the normal number line, in which here is 0 and 1. Right side is for positive integers and left side is for negative integers. This is minus 1, this is minus 2, this is minus 3. In this way, this is the number line. If we have given minus 5 by 2, to represent minus 5 upon 2 in the number lines. At first, this is in improper form. Then make it to mixed. If we make it to mixed form, then this is minus 2 whole 1 upon 2. Minus 2 whole 1 upon 2. This means this rational number will be represents between minus 2 to minus 3. Then look at here. What is in the denominator? Denominator is 2. Then divide this into 2 2 parts, and here is 1, then this is minus 2 whole 1 upon 2 means minus 5 upon 2. Now take another examples. Suppose 11 upon 5. We have to represent 11 upon 5 in the number line. If this is in the mixed form, improper form, make it to mixed form. If we make it to mixed form, this will be 2 whole 1 upon 5. This is 2 whole 1 upon 5 means this can be represented between 2 and 3. Then look at here, what is in the denominator? Denominator is 5. This means divide 2 to 5 into 2 to 3 into 5 equal parts. To divide into 5 equal parts, we have to put 4 lines. 1, 2, 3, 4. This is the 2 between 2 and 3. We divide this number lines into 5 equal parts. Then 1 is in the numerator. This means we have to mark this part. Then this is 11 upon 5 or 2 whole 1 upon 5. Okay. Please students say another examples. Suppose minus 7 upon 3. Minus 7 upon 3 is also in improper form. Then to make it mixed, then this is minus 2 whole 1 upon 3. Minus 2 whole 1 upon 3 means this can be represented between minus 2 to minus 3. In the same way, here the 3 is in the denominator. This means divide minus 2 to minus 3 into 3 equal parts. Then here 1 is in the numerator. Then mark the first one. Suppose I take this between minus 2 to minus 3. As the denominator is 3 means divide these portions into 3 equal parts. To divide into 3 equal parts, we have to put 2 lines. Then 1, 2, 3 equal parts. Here the 1 is in the numerator. This means this first part. Then this represents the minus 7 upon 3 or minus 2 whole 1 upon 3. Then students, I think you can represent any given rational numbers in the number line easily. If you have any doubts, please ask me in my comment box. I promise to clear your all doubts. Please students, I have already told you, do your worksheets, and if any doubt, then ask me in my comment box. Here now till now we have discussed about the addition properties of rational number. Now let us discuss about the multiplication properties of rational number. In the same way, the properties of multiplications of rational numbers. Properties of multiplications of rational number. Multiplication of rational number. Okay, rational number. First property is closure property. Recall the closure property for additions. The addition closure property says that suppose A upon B and C upon D belongs to rational number, then A upon B plus C upon D is also a rational number. In the same way, for multiplications, as A upon B and C upon D are belongs to the rational number set, then the A upon B into C upon D also belongs to the rational number set. This means this satisfies the closure properties. Take in examples. Suppose 2 upon 5 and 5 upon 3. These two are rational numbers. Are these two rational numbers? Please students, recall the properties of rational number. The rational number means the number which can be represented in P by Q form, and where P and Q both are integers and they are in the simplest form, means lowest form, means they do not have any common factors, and q is not equal to 0. Look at here, is 2 upon 5 and 5 upon 3 satisfies all the properties of rational number? Yes, these two are rational numbers. Then multiply these two. 2 upon 5 into 5 upon 3. 5 cancels. This is equal to 2 upon 3. Yes, 2 upon 3 is also a rational number. This means multiplications of rational number satisfies the closure property. Now let us discuss the property 2. What is the property 2? Property 2 is commutative property. Recall the commutative property. The commutative properties of addition says that suppose a upon b and c upon d are two rational numbers, then a upon d plus c upon d is equal to c upon d plus a upon d for addition of rational number. Here for multiplication of rational numbers, the commutative property means a upon b into c upon d is equal to c upon d into a upon b. Now let us discuss some examples for better understandings. Suppose minus 7 upon 5 and 2 upon 3 are two rational numbers. Then for are these two rational numbers satisfies commutative property or not? Then what is the LHS says? The LHS says that a upon b plus c upon d. This means minus 7 upon 5 into 2 upon 3, which is equal to minus 14 upon 15. Then take the RHS. RHS means 2 upon 3 into minus 7 upon 5. When we multiply this, we get minus 14 upon 15. This is the result of LHS and this is the result of RHS. These two are same. This means LHS is equal to RHS, which shows that multiplications of rational number satisfies the commutative property. Now let us discuss the third property. The third property says that associative property. Associative property. Please students recall the associative property of additions. The associative property. Now the please students note the important points. I will discuss the associative property in my next page because here the page is filled with writings. Then next page, in my next page, please students note down the important things. Then in my next page I will discuss about associative property. The associative property says that a upon b, c upon d and e upon f are three rational numbers. Associative property says that a upon b into c upon d into e upon f is equal to a upon b into c upon d into e upon f. Now take an examples for better understandings. Minus 3 upon 5 is a rational number. Minus 7 upon 2 is another rational numbers. Then 11 upon 3 is another rational numbers. This is a upon b, this is c upon d and this is e upon f. All these three, note down. Look at here, all these three are rational numbers because all these three satisfies the properties of rational numbers. Now take the LHS, the LHS says that minus 3 upon 5 into minus 7 upon 2 into 11 upon 3, then which is equal to minus 3 upon 5 into minus 77 upon 6, which is equal to 2. Then this is equal minus plus 77 upon 10. This is the LHS. Now take the RHS. The RHS says that a upon b into c upon d, whole into E upon F. Then minus 3 upon 5 into minus 7 upon 2 into 11 upon 3. Then which is equal to minus 3 into minus 7 means plus 21 upon 10 into 11 upon 3. Then here 3, this is cancels, this is 7, which is equal to 77 upon 10. Then this is RHS and this is LHS. Look at here, LHS is equal to RHS. This means multiplications of rational numbers satisfies the properties of associative properties. Now let us discuss the fourth property, identity property. Then what the fourth property says? The fourth property is identity property. What is the identity? One is called the multiplicative identity. One is called the 0 is called the additive identity and 1 is called the multiplicative identity. For any rational number p by q, 1 is a identity which is p by q into 1 is equal to 1 into p upon q, which is equal to p upon q. Now take an example. Suppose minus 33 upon 4 is a rational number. Minus 33 into 1 is equal to 1 into minus 33 upon 4, which is equal to minus 33 upon 4. Am I right? Is there any wrong step? No. This means multiplications of rational number satisfies the identity property. 1 is called the multiplicative identity. Then for any p by q rational number, there exists the identity 1 in such a way that p upon q into 1 is equal to 1 into p upon q, which is equal to p upon q. You take any rational number. Suppose you say minus 7 is also a rational number. Minus 7 means minus 7 upon 1. Then here also if you multiply it with 1, then this is 1 into minus 7 upon 1, which is equal to minus 7 upon 1 means minus 7. This means minus 7 is also satisfies the identity property. Now let us discuss the fifth property. What is the fifth property? The fifth property is the inverse property. Here the page is filled with writings. Now students, please note down the important things, and in my next page I will discuss about the inverse property. If anyone any doubt, please ask me in my comment box. Here the fifth property is the inverse property. What is inverse property says? The inverse property says that for inverse property, fifth property says the inverse property of multiplications. For any p by q rational number, there must exist a q by p such that p upon q into q upon p is equal to 1. Multiplicative identity. Take any rational numbers. Please take an example. Take any rational numbers. Suppose I say minus 5 upon 7 is also a rational number. For minus 5 upon 7, then this is minus 5 upon 7 satisfies all the properties of rational numbers. This means minus 5 upon 7 is a rational number. Then there must exist minus 7 upon 5. Minus 7 upon 5 is the reciprocal of minus 5 upon 7. Then when we multiply minus 5 upon 7 into minus 7 upon 5, this is equal to 7, 5 cancel, minus plus, which is equal to 1. 1 is the multiplicative identity. For any rational number, suppose I say 4 is a rational number. For 4, the reciprocal of 4 is 1 upon 4. 1 upon 4 is also a rational number. This means multiplications of rational number satisfies the inverse property. If we multiply 4 into 1 upon 4, which is also 1. For any rational number, there must exist its its reciprocal, which is also a rational number. Then when we multiply the rational number with its reciprocal, we get 1, which is the multiplicative identity. This means multiplication of rational number satisfies the inverse property. Now let us discuss about the sixth property, distributive property. What is distributive property? Distributive property says that suppose A upon B is a rational number, C upon D is another rational number, and E upon F is another rational number. A upon B into C upon D plus E plus or minus E upon F is the distributive property says that which is equal to A upon B into C upon D plus or minus A upon B into E upon F. Now take some examples for better understandings how the multiplications of rational number, this is the satisfies the distributive property. Then take an examples. Suppose 2 upon 3, 3 upon 5 and 5 upon 7. These three are rational numbers. Then take the LHS. Here take the LHS. 2 upon 3 into 3 upon 5 plus 5 upon 7. Then the RHS must be equal to 2 upon 3 into 3 upon 5 plus 2 upon 3 into 5 upon 7. Then take the LHS and solve the RHS. If we get LHS is equal to RHS, then can we say that this satisfies the distributive property. Then the LHS says that 2 upon 3 into 3 upon 5 plus 5 upon 7, the LCM is 35. Then here the 7 3s are 21 plus 25, which is equal to 2 upon 3 into 46 upon 35, which is equal to 92 upon 105. 46, yes, 46 upon 35. This is 92 upon 105. Then is there any common factors? No, I think no. Look at here. Then take the RHS. Here take the RHS. Here the RHS is 2 upon 3 into 3 upon 5. 3 cancel plus 2 upon 3 into 5 upon 7. This is equal to 2 upon 5 plus 10 upon 21. Then here the LCM is 105. Then this is 42 plus 50, which is equal to 92 upon 105. Then this is the result of LHS. This is the result of RHS. Yes, we get here LHS is equal to RHS. This means this satisfies the distributive property. Then thank you students. Today this much. In my next class, next lecture, we will continue with this. Thank you students. Please